Now that you guys are so good at doing the law of sines, let's use this formula in some word problems. All right, let's take a look at a variety of setups so you'll be ready for anything you might see. Find the height of the bridge, if the length between the two sides is 560 feet across. Okay, so across is 560 feet. And what they want us to do is find the height. Okay, there is a triangle I notice here. Okay, and some people want to go ahead and draw that height, except I cannot take 560 and chop it in half. That clearly is not half. If these are different angles, then these are different sides. Okay, so maybe what I'll do is just draw this picture over here for you. It is a triangle. It's not a right triangle. There's a 64-degree angle, a 72-degree angle. Okay, so if you know two angles, you can go ahead and find that third angle for me. Please do that. Okay, what'd you get? 44 degrees. Okay, and this side is 560. Now what I really want to find is the height, but I can't do that until I find one of these sides. So it doesn't matter which one you pick. I'm going to pick this side right here. And I'm going to do some law of sines calculation. The sine of 44 degrees over 560 is equal to, let's use sine of 72 degrees over side x. Okay, sometimes people call these a walkabout problem. We're going to be finding side x right here, which we don't really need, but I am going to use that to help me find the hypotenuse. Okay, so step one, let's find x. When we cross multiply, it's x times the sine of 44 equals 560 times the sine of 72. We'll have to divide both of them, so I'm just going to use my calculator here. 560 times the sine of 72. Let's divide that by the sine of 44 degrees. And what we're getting here, x is approximately, let's round to two places, 766.69 is followed by a 5, so let's round 69 up to 70 feet. Okay, so that's this side right here, 766.70. Okay, well, why are we finding that side? I need to find something in the big triangle that will now help me solve to find something in this little triangle. So now I'm going to look at just this little right triangle right here. This is a right triangle. I've got an angle of 64 degrees. I know this, which is the hypotenuse, and I'm trying to find h, which is the opposite. So now this is just a basic Sohcahtoa problem. Which trig function uses opposite hypotenuse? Sine of 64 degrees is opposite h over hypotenuse 766.70. So maybe what I'll do is I'll take the answer in my calculator, which is right there, and I'll times it by the sine of 64 degrees. So h is approximately 689.10 feet. Okay. If you have a number that you've rounded earlier, and you could take all those decimals and then take that answer, okay, and then just multiply it in the calculator, that would be more accurate. Okay, a lot of the problems when you're doing trigonometry, you might have to find something you don't need in order to find something that you do need. Okay. All right, let's take a look at the next one. We're looking up at the top of a beautiful pine tree with an angle of elevation of 57 degrees. Okay, so the first thing you always want to do when you're doing word problems is draw the ground. Okay, you need to have a base. You need to have a bottom horizontal, and we look up at the top of a beautiful pine tree. Okay, here's my beautiful pine tree. Yep, kind of weird. And the angle of elevation from horizontal up is 57 degrees. Okay. He then walks 10 feet closer and looks up at the beautiful. Okay, so this is where he started. He walks. So this distance right here is 10 feet closer. He looks up at the beautiful pine tree. Remember when you go to the show and you sit closer, like in row 1, you gotta really crank your head up. But the farther back you sit, the angle that you have to tilt your head should not be as much. So this angle should always be bigger. This angle is 65 degrees, and that makes sense. Okay, how tall is the beautiful pine tree? Okay, so what we really want to find here is h. You have to make sure that you use a variety of variables. Don't put x everywhere. You have to use different letters. So the thing that I really want to find is the height of the pine tree. And I'm noticing there's a little right triangle right here, but I don't know anything about this except for the 65-degree angle. There's no way I'm going to be able to find any information here. I know something about this 10, okay, but that's not part of the big triangle. 10 is part of this obtuse triangle. So what we're going to have to do is work with the obtuse triangle here. We might have to find something about him, and then we'll use that to help us find something with this little triangle. And the thing that's connecting them all together is this side right here. I'm going to call this x. So I've got one unknown x that I'll find first, then that'll help me find h. Okay, so let's go look at this obtuse triangle. I only know one angle, but actually we can subtract from 180. This is a linear pair right here. We can figure out this obtuse angle. 180 minus 65 is 115. And then if you could subtract from 180, this little angle up here in the corner is, wow, what is it, 8? Okay, super tiny. Now we know all three angles and one of the sides. And what I'm going to try to find is this side. Let's use our law of sines. So I have to use the 10, right? So we're going to do law of sines. The law of sines is going to come in right here. Sine of 8 degrees goes with the 10. Okay, remember we're trying to find x. So what angle does that go with? Go across 57. Sine of 57 degrees goes over x. All right, I'm going to cross multiply here. X times the sine of 8 equals 10 times the sine of 57. What I'm going to want you to start doing is not type anything until the very, very end. So I'm going to divide both sides by the sine of 8, but just with my pencil. So the calculation formula here for x would be 10 times the sine of 57 divided by 8. But let's just hold off with typing that in. Now let's go take a look at how we're going to use x to find h. So now what we have is just a basic right triangle, basic trigonometry. I've got a 65-degree angle. X for this right triangle is hypotenuse. And the height here, this is the opposite. Okay, so now when you have a right triangle, you could do the law of sines, or you could just do Sohcahtoa. Okay, and Sohcahtoa is actually just Sohcahtoa here, the law of sines, but for only right triangles. So opposite and hypotenuse is going to be sine. The sine of 65 degrees is h over x. H over x. And if we cross multiply here, x times the sine of 65 degrees is what our h is. And what we're going to do is we're going to take this x value, we're going to substitute it in right there, take this answer, times by sine of 65, and we'll have our h. Okay. Variety of ways that you could do this. You could do it all at once, of course, or you could take answer and times by. Okay, so let me just show you answer. If I use the alpha y equals, stuff is definitely easy. 10 times the sine of 57 divided by sine of 8. Okay. And you could hit enter, or you could say, let's times that. Let's multiply that by the sine of 65 degrees. Okay, so I haven't chopped anything until the very, very end, and the height for this problem is approximately 54.61. How about some units? This is feet. Feet, that makes sense for a tree. Okay, total answer, nicely rounded at the end. All right, what else can we do with law of sines? While snacking on a bag of Doritos, whoa, Jason is overcome with the need to find out how big the average Dorito chip is. Okay, so he takes an average Dorito chip, not the little tiny crumb, but like a regular one, and he finds, let's see, here's the chip, okay, that the sides are 4, 4.5, and 4.8. On average, most of them are about this. Okay, what is the area of this Doritos chip? Okay, so I want to know the area. So should I do Sohcahtoa? Should I do law of sines? Wait, hang on. This one said area. We gotta use one of those fun area formulas. Do you know which one uses all three sides? Okay, the right one here would be Heron's, of course. Heron's formula. To do Heron's, the first thing you have to do is semi-perimeter. So we've got semi, and then the sum of the four sides, okay, is, pause the video, go ahead, find it. All right, are you back with the answer? Did you get 6.65? Okay. Don't chop any of that off, keep that whole. And then area is big, big radical. We're going to take 6.65 by itself. And then 6.65, subtract off one of the sides. 6.65, subtract off the next side. 6.65, subtract off the last side. Draw a longer radical bar if it didn't cover it. Okay. And the area is approximately how many centimeters squared? How many centimeters squared? Let's see if you're playing along. So tomorrow I'll check the answer for number 3. All right, what else do we have for area? We've got a couple of girls here, and they are standing 308 feet apart. So when you draw the girls, make sure that we've got one of them on this side, one on this side, and the distance between them is 308 feet. Okay, and they look up and they see a blimp, okay, between them. Is it exactly between them? I mean, between doesn't necessarily mean right in the middle. So maybe what I'll do is draw it off to the side a little bit. Blimp, blimpy. So it doesn't look like it's the middle. Anna looks up with an angle of elevation of 38 degrees. And Lexi looks up at an angle of 41 degrees. Okay, oh, so the sides are definitely not equal because the angles are not equal. How high up is the blimp flying? So what they really want us to find here is the height. This is the height, except the number 308 is part of the large triangle. I cannot use 308 on either of these smaller triangles to find the height. So this is another example of work. And I have to find something we don't know just yet in order to help us find something we do know. If you take a look at the big triangle, we have a side of 308. We have a side or an angle of 38 degrees, 41 degrees. If you know two angles of a triangle, you automatically know the third one is how much up here? 101 degree. Okay, so let's find something from this big triangle that I could use in one of these smaller triangles. I'm just going to randomly pick a side here and call it X. So I'm going to find X. That'll help me find H. Okay. This obtuse triangle here is not a right triangle, so we're going to have to do law of sines. So let's see. Sine of 41 degrees goes with the X. And now let's pick another ratio where we know both the numbers. How about sine of 101 goes with 308? Okay, and if you cross multiply there, x times the sine of 101 equals 308 times the sine of 41 degrees. X times the sine of 101. Let's divide both sides by the sine of 101. I wrote a couple steps there at once. If that's too confusing, do a couple lines of work. Okay, but I didn't want to know x. I wanted to find the height. So now that you found something from the big triangle that's related to the height, let's go ahead and do our basic Sohcahtoa. So I'm going to have to use this triangle over here because I know the hypotenuse, I know the angle, and I know the opposite. So looking at this right triangle now, we know we have the calculation for hypotenuse, and we're going for opposites. So let's make a sine problem. Sine of 38 degrees is opposite h over hypotenuse x. You could do law of sines. You'd say sine of 90 over x. Sine of 90 is what? Oh, sine of 90 is 1. So that just kind of cancels out. All right, and then we're going to cross multiply here. X times the sine of 38 degrees is h. So now you're going to take your calculator, you're going to take this x, pop it in right there, multiply by the sine, and the height of this blimp is approximately how many feet squared? For people that are listening with sound, go ahead and type that in. And the correct answer, for people that want to know, is 126.73 feet. Oh, it's just feet, I'm sorry. It's just feet. Okay.